So, hello guys, you are welcome once again to another video of mine. This is the second day on our UTME and Waec 2022 physics topic by topic wise. And I've told you why you need to join this particular class. If you are writing exam or you know somebody that is writing the exam, kindly share the content with them. And if you find anything interesting, you can try and subscribe to the channel. So because of time, we don't want the video to be lengthy. So, and we want to make sure that everybody is getting it. And if you have any issues, you can always send me a message either via email or any of our other social media platform. So let us start with the first question of day two, Newton laws of motion, friction, and circular motion. Only 10 questions, and we are taking it with respect to the syllabus new pattern. So we have three blocks, A, B, and C of masses, 4, 2, and 1 kg respectively, are in contact on a motionless surface. As shown, you can see that means they are together. If a force of 14 Newton is applied on the 4 kilogram block, that was a force of 14 Newton on the 4 kg block, then the contact force between them is between A is that you can see A is bigger than B, B is bigger than C. So because we are actually talking about Newton laws of motion, the total force on this three body is always given as force is always given as the product of the mass and its acceleration. So F is equals to ma. Now from here, the total force is 14 is equals to the total mass of this body are 4 plus 2 plus 1. 4 plus 2 plus 1 is 7 multiplied by the acceleration. So we can say acceleration here is 14 divided by 7. Everybody know that is our 2 meters per second squared. Fine. But the question asks about the forces that is acting where at this point A. That is if you apply a force F at that point. So if we want to go by that, it's very simple. So if we use secondly or a continuation, F is always equals to ma. So far, we know the acceleration of the body. The acceleration it will take the three body to move is now 2. To now get the force acting on A, the mass on A was 4. So we can say this is nothing but F is equals to, as you can see, we are talking about the force that we act between A. So we are the two force acting between A when A is set to motion is the total mass of B and C, contact force. So that is the total mass that we act because it was when force was applied to A, then what we have what it will definitely transfer to B and C. So the mass of B and C is 2 plus 1, that is 3, multiplied by the acceleration of the system, which is 2. So the force, contact force between A is now equals to 3 times 2, and that will give you 6 Newton. Please, it's a very technical question. Looks simple, but it is not that simple. So the answer to that is choice A, and that is the question answer for the first question for today. The second one, a particle of mass is 0.3 kilograms subject to a force F equals to negative Ks. That is Newton law of motion. We are talking about spring forces and spring constant. And K, which is force constant, is 15 Newton per meter. What will be the initial acceleration if the force is released from a 20 centimeter? Fine. We have studied just now that force is always equals to product of mass and acceleration. We are also given the force of a spring balance as negative Ks in modulo form. Modulo will give you positive. That is F is equals to Kx. This is a force. This is also a force. So now we are trying to say when the body when the force was applied to the body will start accelerating. Force is a vector quantity. So having said that, we can now compare the two things because this is F, this is also F. So we can say that MA is equals to KX. As you can see, it is, the forces are conserved. Now, from there, we can conclude the mass of the body given was 0.3. We are looking for the acceleration. That was what? When the force was applied. The force constant of the body given 15. Then the extension of the body, if you like to say the distance, is 20 centimeter. Physics students know you have to what? Convert that to what? To what you call a meter, because answers here are in meter conversion. You can see meter, centimeter. This is 20 over 100 for beginner, and 20 over 100 is like 1.5, or you say 0.2. I'm going to use 1 over 5, which will make my work very, very simple because I don't have time to be using calculator. So 5 here 1, 5 threes are 15. So directly I can say 0.3 of acceleration is equals to 3. By making A the subject of the relation, say 3 divided by 0.3, and that should give us 10 meters per second squared. So that is the answer for the second question. And I think that is choice C, which is also not difficult. So the concept we are doing so far so good is the concept of force acting on the body is equals to the product of mass and the acceleration of the body. The next phase. About the next question we have, if a stone is thrown out of an accelerated train, there is an accelerated train, and a stone was being thrown out from an accelerated train, then the question is the acceleration of the stone. There is a stone that was thrown out inside a train that is moving. Then acceleration of the stone at any instant depends on dash. This is still the same law we are talking about. I don't think students should have issues with this. We have talked about F is always proportional to acceleration when mass is constant. That is the way the formula was being coined. So without wasting time, when the body is what is accelerating at any instant, at any point, it is always proportional to the force. Please always keep that at the back of your mind because F is proportional to A. And you guys know the famous formula we have been talking about since morning. F is equals to MA. So where F and A are vector quantities. So the simple answer to that is at any instant, it is always going to be equal or proportional to the force acting on it at any instant. Acceleration of the train, accelerated train, it cannot be proportional to the acceleration. Please note that the acceleration of the stone is not proportional to the acceleration of the train. So please, it is wrong. So the correct answer to this is nothing but option A. So A is correct, my dear students, and that is the right answer to that. The next one. An object of mass 10 kilograms is moving at constant speed of 10 meters per second. A constant force that acts for 4 seconds on the object gives it a speed of 2 meters per second in opposite direction. Let me be able to tell you that the only technicality there is opposite direction. And if you want to go, the force acting on the object, which was the question, is always equals to your second law of motion, which is basically law of rate of change of momentum, which we have studied under the concept. Now, because we are only solving question, we are still using F equals to ma. A is V minus U over T, which you write as F equals to M dV by dt. And you know by dV by dt, M dV rather, is called rate of what? This is called change of momentum. M dV is called impulse of rate of change. So we say this is the law of rate, because there's a time, rate of change of momentum. I'm not supposed to waste time here, because it is just for us to get prepared. If you want to watch concepts, they are always available for you on the channel. So for now, like I said, we are looking for the force. The mass is given to be 10, that is 10 kilogram. The speed at constant speed, that is what we need to understand, of 10 meters per second. We have 10 minus initial speed, you can take 0. Very good. I love this question because we have 10 minus 2. That is good. So look at this now. We have the constant speed was 10. Then it gives a speed of 2. We need to be careful. So we have to do it the way it is supposed to be done. Sorry, I think something is missing there. Very good. We are back. So now here it should be the final speed it gave was 2 minus the initial speed was 10. Everything divided by 4. On simplification, and say 10 into brackets, we have this is negative 8, if I'm not mistaken, over 4. So this is equals to negative 80 over 4, and that should give us negative 20. So place Newton. So let's see if there is a mistake or I have a mistake of interpretation. Let's check again. The mass is 10. The constant speed is also 10. The constant force acts on the body for 4 seconds. Very good. We have 4 seconds. That is nice. Then it gives a speed of 2 meters per second. That is 2 meters per second in opposite direction. In opposite direction. You can see the mistake. I will have scaled this. In fact, I am lucky that the option is not there. If the option is there, I will have scaled it. Please, you can see opposite direction. I underline. I did not follow the line of the question. Opposite direction tells me that what we are talking about relative speed, which we have also talked about. So what I'm trying to say here is that the direction of the force is like you are having relative velocity. So relative velocity of the body is equals to in opposite direction. We've talked about that. So what we are doing is that we are saying 2 minus, some of you will say 2 plus 10. But the best way to do this should be 2 minus 10, which is very good. So which I think we've talked about. When bodies are moving, I move a step towards you, you move a step towards me. What we'll do is what the total number of steps that we have moved is going to be your step plus my step. That is what we call relative velocity. Let's keep that in mind. So the first one was 2. The second one was what? Was 10. So what I'm going to do now is going to be something like, okay, fine. 2 minus 10. Because the opposite direction tells me the other force velocity is not in that direction. Because of time, let's just say we have 2 minus 10, which we turn to a 2 plus 10. So, and that is 2 plus 10 we give us, you can see this is 12. So, and if we have 10 times 12, it's going to give us 120. So that is 120 divided by 4. And that is going to give me 30 minutes. So we just need to be careful sometimes about this type of what? This type of question. And let it be known that what the force will also move in opposite direction. I like technical questions because you can easily make mistakes. Now, please, the work I have done here is only I have always obeyed the law of what? Relative velocity. A step, the 2 steps are 10 plus 2, which is 12. And the force will also move in opposite direction. And because of that, I am going to pick option B, which is negative 13 years. I hope you understand this. This is very important. You don't pick wrong answer. The next question. Now, about the next question, we have a block of mass 4 kg is suspended through 2 light spring balance. The balance is A and B. Then A and B will read respectively dash. The weight of a body, we've talked about this time and time. For those who are joining, who are part of my class, the weight of the body is always acting downward. There is a tension in the string, which always acts away from the point of contact. So we say the tension here will balance the weight. We don't need to waste our time. So far, the total weight acting on this is the weight of the body is 4 kg. So the amount of the weight or the amount of mass that will act on what? weight is mg, but we are talking in terms of the masses as weight here. So the amount of mass that we act in both A and B are equal. And see, tension is equals to weight. So if here is 4, this is also 4. This is also 4. So A is equals to 4 kg, and also B is equals to 4 kg. Please keep that in mind. Tension always acts away from the point your weight is always acting downward. So both are going to be 4 kg respectively, and that is the way we do it. So note that. So the answer to that is 4 kg. No doubt about it. The next question. About the next question, we have a hammer weighing 3 kg strikes the edge of a nail with a speed of 2 meters per second, and it drives it by 1 centimeter into the wall. The question says the impulse imparted to the wall is dash. So I think this is now still on application of momentum, which is laws of motion. Then doing this directly, change in momentum is called impulse. The body was imparted force, that is impulse. Impulse is called change in momentum. From junior classes, impulse is written as change in momentum. Basically, you say mv minus u. The way you interpret it, there is a wall, then the final velocity will be 0 because the body is going to rest, it's coming to rest after it's in the wall. So we can just take it very simple. The impulse on the body is a simple question. The mass of the body was 3. The change in velocity of the body was we have 2 minus 0. So which is very simple to do. This is 3 times 2, that is 6 Newton per second. Please note that. Impulse is also given as what? Force times time, from what I did in the previous slide. This is a simple question. I don't expect anybody to miss. All this topic is very easy, and these are things you see in your or during your examination. So you take them very very important. You can say mv minus mu, or you say what? Another SI unit for impulse is kilogram. You can say Newton seconds or kilogram meters per second. So both are valid SI units for impulse, which is called change in momentum. These are simple level of questions I believe everybody should be able to get. The next one, my dear student, is a very popular question, which is the force required to stop a car of mass 800 moving at a speed of 20 meters per second over a distance of 25 meters in 2.5 seconds. So still the same concept, like I said, this section is a very simple question. F equals to m into bracket 2, as you say, v minus u over t, or F equals to ma, as a is v minus u over t. So if you want to do that directly, you can just apply the formula directly and you have the answer. The force is equals to the mass, which was 800 multiplied by, you have 20 minus 0 over 2.5. So directly, this should give you F is equals to 20 over 2.5, that is 8. 800 times 8 should be 6,400 Newton. So please be careful, because some of you will be like, I did not use the parameter, which was the distance. If you think you want to use the parameter, you can go by your formula of speed equals to distance over time. So if you need that, you can also go by that. Or acceleration equals to v minus u over t is what I use here. You can use v squared equals to u squared plus 2ax to get the value of your acceleration. Then you use these two. So it's not all parameter that is given in question that you're supposed to use sometimes. Because I know a lot of students from my teaching experience that will be saying, okay, we didn't use this parameter. All parameter may not be used. So far, equation of motion as what gives you the same formula which you can use, and it's always going to give you the same answer. So if I use v squared equals to u squared plus 2as to get my acceleration, I'm still going to get the same answer. Please note that. The next question is question 8, I guess. This says the force F acting on a particle of mass m is indicated by the force time graph shown below. The change in momentum of the particle is dash. I think I did this more recently on my page, talking about the rate of change of momentum, which is called impulse. Whenever you have a force time graph, the impulse acting on the body, which is called rate of change in momentum, is always equals to area under the force time graph. So I think this is just a subset of what we have studied before. And this is just the right time for you guys to know how to do that. So to get the impulse acting on a force time graph, you just find the area under the curve. So looking at the area under the curve, you know you have to shade as usual. So if you shade this place, you consider this one as a triangle. That's the area of triangle. You consider this one like a rectangle, and also consider this one like a rectangle. So you just get the area of each of them. And having done that, you just add them together. You have the answer for your impulse, or what we call change in momentum. I hope you understand. So from area of triangle, so area under the curve, area of triangle is a half base times height. Look at this. So impulse will now be the area of the triangle half times the base. I'm taking this to be 2. Hopefully, it will be 2. And the height is 6. 2 times 6 plus. Then this one, I'm taking this to be 2. Length times breadth, you can see. This is 3. This is 3. And I have, this is breadth. You can see what I'm trying to do here. I'm taking this point and this point. So here, what I will do, because I have to be careful, is I say 4 minus 2. Interval with this is 4 minus 2. That is the length. 4 minus 2 is 2. And the width or the height is 3. So let's just follow that. Please be careful. And in this case, I'm taking this place to be 3. I'm taking this place to be 8. So 8 minus 3 will be the length. 8 minus 3, that is 5. Then 5 multiplied by, you take this one also to be 3. I just hope this is correct because of errors I'm seeing. Look at what I did here, guys. This is my rectangle. Length times breadth. So length times width. Length times width. So my length here is the distance from this point 2 to 4. So I subtract 2 from 4. I'm taking 2 from 4 to be equals to 2. So I take my length to be 2. And my breadth. Look at this. This is where something is. Look at the breadth. I'm taking it with respect to what I have here as a point of what? 3. So then plus the last one, the length is from 8 to 12. I think this space should be 4, but I'm thinking this space is 3 because the way it was indicated, it was not placed directly on 4. So maybe it's 3. The answer might not be accurate. I'm not so sure. I don't know. So, but if I take it as 3, it will be 8 minus 3. That is 5. Then I will take this one also as the height of this place is also as 3. So you can say if I take this place as 8 minus. So look at what I'm trying to say. If I take the breadth as this place is 3 multiplied by 5. I'm just taking a random value because I cannot see that scale. So I say 6 plus 6 is 2 more plus 15. So this is like 6 plus 6 is 12. 12 plus 15 is 27. So I'll go for this answer because that's the closest answer here, according to what I have here. Or basically, let's see that again. The only thing I can say here is base is 2. 2 minus 0 is 2. Height is 6. This is correct to scale. If we take this one as, if I take this one as 3, this went as 3. Now, this will be 3 minus 2. That is 1. That is 1. So if I take this one to be 3, that is 3 minus 2. That is 1. Then I take this one as 3. This will be 3 just to work with the answer. So that means this space is 3. Then that is 8 minus 3. I took this one as 5. Then the height is 3. You can see 5 times 3. I think this space is what? This point here is 3. Dear student. So that's 3. Then it will make the answer to be correct now. 6 plus 3 is 9. 9 plus 15 is nothing but what? But 24 newtons per second. So guys, that is the way we do that. It's a simple thing if you know concept, and concept is always what? The leading factor in physics. So the last two set of questions that we have for today is a conveyor belt is moving at a constant speed of 2 meters per second. A bus is gently dropped on it. The coefficient between them is we have a coefficient of friction, which is called mu, is 0.5. The distance that the bus will move relative to the bed before coming to rest is that. So guys, we are looking for the distance. And if we need the distance, we need to understand, we can draw because, when I'm doing my concept, I used to draw. I am what? I am used to drawing. So And that is the best way to understand how to solve questions. But because this is just UTME question and Waec question, that you need to get the answer as quickly as possible. So that is why most teachers don't fancy drawing when they believe you already know the concept. So, but to understand it very well, the speed was given to be, V was given to be 2 meters per second. The coefficient of friction is mu, was given to 0.5. It is a dimensionless quantity. You are looking for the distance s the body has moved. That is a question mark relative to g, which was given to be 10 meters per second square. And these are the parameters that was given. So there is a frictional force acting on the body when the what? When the bus is what? Is gently dropped on the conveyor belt. So if we go by the friction formula, F equals to mu R, or if you say mu N, where N is always normal reaction, that is my own way. You people call it R, but I love calling it N. So which is the same thing. F equals to what? From the topic we are talking about, MA equals to mu, normal reaction is equals to mg, and this is mg. Just for you to see, m gets cancelled out. Some of you already know this formula, that a equals to what? Mu g. So let me get the acceleration of this body when the box was dropped on the bus. The value of mu is given to be 0.5. I'm multiplying that by the g, which is 10. Without wasting time, this is giving me 5 meters per second square. That is the acceleration of the body after the box was gently dropped on it. But I'm not looking for the acceleration, I'm looking for the distance it has moved. From my equation of motion formula, v square is equals to u square plus 2as. So if I go with that directly, I can say we have, I'm looking for s, definitely we are having, it should be minus 2s because it's going what, you know what I mean by that. Okay, it is coming downward. Please note that. Okay, we have v square. What is my v? 2 squares is equals to 0 plus 2 times 5 multiplied by the distance you are looking for. 2 squares are 4 is equals to 10s. On simplification, 2 times 5 is 10. This is s. You can say s is equals to, let me change the marker. You can say from here, we can say s is equals to, I'm taking it from this point, my dear students, 4 divided by 10, which is simple as what? 0.4 meter, which we value with what's valid with option D according to the exam. So that is the answer to that. And I think you understand how to do that when next you face question like that. Then the last question for today is, it is difficult to move a cycle with brakes on. When the brake is on, that is, maybe you are actually having a motorcycle and you hold on the brake and you're trying to move it. This is on the concept of friction, and I think this is also very simple. This is a combination of friction plus Newton law of motion, and these are the way you see questions in JAM, especially nowadays. So you need to know them, not just by knowing the formula, the interpretation also matters. So when brake is on, you will definitely know that the tires will be sliding. Normally, if brake is not on, when you move a cycle or a motorcycle, for understanding sake, the tires will be rolling. When you don't hold the brake, it is when you move a bike. Just imagine yourself moving a bike, the tire will be rolling. So they have rolling. But when you hold on to the brake, the tires are going to be sliding. So because sliding friction is more than rolling friction. Please note that. Rolling friction is more like kinetic friction. Please note that. Or what you call dynamic friction. We've talked about this more and more again about friction, types of friction, and interpretation of friction, and what friction depends on. Please, you can watch the friction video to understand concept very well. But this is a simple question. As when braking on rolling friction opposes motion on road. Rolling friction definitely opposes motion. But rolling friction cannot, because when something starts rolling, it can start moving. Sliding friction opposes friction. Now, that is not why it is difficult to move it. It is because the sliding friction is more than the rolling friction. If sliding friction is more than rolling friction, the body will not move easily. Do you understand? So rolling friction is not. This is very wrong. This is wrong. This is wrong. So the correct answer is sliding friction is more than rolling friction. That is why the cycle will be difficult to move. Not that you can't move it, but it is very difficult because the sliding friction is more than the rolling friction. So guys, This is where we are going to stop for this section. Tomorrow is another day. You can join us tomorrow for the next topic of tomorrow. So, guys, see you guys soon. If you find any of this video interesting, you can share the content with your friend and you can as well subscribe to the channel. Bye for now.